$3. That is all it costs to set up a water purification system that the bottled water industry, a sector valued at over $350 billion in 2024, has spent decades making sure you never think about. Not a filter with replacement cartridges, not a subscription service, not a machine that breaks down and needs a technician. $3 of colloidal silver solution, a clay ceramic pot you can build yourself from local materials, and water that comes out the other side with between 97.8% and 100% of bacteria eliminated. Confirmed. Published in peer-reviewed literature. Tested in field conditions across 3 continents. And priced so low that no company on Earth has a meaningful financial incentive to put it on your radar. This is not alternative medicine. This is not fringe science. This is the same technology that NASA proposed in 1974 for purifying water aboard the Space Shuttle. The same principle the Russian space program applied to the Mir station and continues to use on the Russian side of the International Space Station, and the same mechanism that was validated in a 2008 study published in Environmental Science and Technology by researchers at the University of Virginia. The conclusion of that study was precise. Silver-impregnated ceramic filters show promise as an effective and sustainable point-of-use water treatment technology. Effective, sustainable, made from local materials and labor. $3. Before we go further, consider what is actually at stake economically. The global bottled water market generated more than $350 billion in revenue in 2024 and is projected to exceed $578 billion by 2032. Nestle, Danone, Coca-Cola, and PepsiCo dominate the sector. These are not companies that sell water. They sell the absence of a better idea. The moment a household understands that bacteria-free drinking water can be achieved with fired clay and a few cents worth of silver, the business model collapses. No patent, no subscription, no replacement cartridge every 3 months, no call center, nothing to upsell. The method cannot be owned, and that is precisely why you have never seen it featured in a home improvement segment, a government health campaign, or a mainstream media article about water safety. The history of silver as a water purifier stretches back 2,500 years and crosses civilizations that had no contact with each other. The oldest recorded account comes from Herodotus, the Greek historian writing in the 5th century before the Common Era. He documented that no Persian king, including Cyrus the Great himself, founder of the Achaemenid Empire in 550 BC, would drink water that had not been transported in silver containers. The Persian royal army traveled with wagons carrying silver jars specifically to keep drinking water fresh during military campaigns that lasted months across hostile terrain. This was not luxury. This was military survival strategy. The Persians understood something empirically that science would not confirm for another 2 millennia. Silver prevents bacterial growth in water. The ancient Phoenicians and Romans arrived at the same conclusion independently. Roman households kept silver coins in drinking vessels. Roman physicians of the 1st century documented the medicinal properties of silver preparations. Chinese emperors and their courts ate with silver chopsticks and stored drinking water in silver urns, a practice documented across the Han dynasty. And during the Napoleonic Wars, the armies of Tsar Alexander of Russia stored and transported drinking water from rivers and streams in silver-lined casks, a practice that continued through the Second World War among Russian military units operating in the field. The first modern scientific documentation of silver's antibacterial properties came in 1893, when the Swiss botanist Carl Wilhelm von Nageli published his findings on the toxic effect of metals on living organisms at extremely low concentrations. He called this phenomenon the oligodynamic effect, from the Greek for small force. He demonstrated that silver destroyed algae, bacteria, and other microorganisms at concentrations so minute they could barely be measured with the instruments of his era. His findings were published in the Proceedings of the Swiss Naturalist Society. The scientific community took note, and over the following decades, silver found its way into wound dressings, surgical tools, and eventually water systems. The military application came next. During the Second World War, the United States Army conducted field trials using silver-based water purification systems for troops operating in environments where safe water was unavailable and chlorine tablets were impractical. By the 1960s, NASA scientists at the Johnson Space Center had developed a compact silver ionization system for recycling and purifying water aboard spacecraft. a system that needed to work for months without resupply, without mechanical failure, and without producing chemical byproducts that would contaminate a sealed cabin environment. The Russian space program chose silver nitrate for the same reason. Silver was the only purification agent that met the combined criteria of effectiveness, chemical stability, and safety at the concentrations required. Decades later, those systems are still operational on the International Space Station. The modern ceramic filter was formally developed at the Central American Industrial Research Institute in Guatemala in 1981. Researchers there combined two ancient technologies: the clay pot filter, which cultures from Egypt to pre-Columbian South America had used to remove sediment from drinking water for centuries, and the silver impregnation method that the Persians had applied to their military water supply more than 2,000 years earlier. The result was a colloidal silver filter, a fired ceramic pot coated with elemental silver particles that simultaneously traps bacteria through physical filtration and destroys surviving microorganisms through silver's oligodynamic action. The organization Potters for Peace subsequently distributed this technology to communities across the developing world. 2-year-old filters and 7-year-old filters both tested as fully functional. The silver does not wash away. It stays embedded in the ceramic matrix and continues working. In the description, you will find a complete guide with everything these ceramic filtration specialists apply in field conditions that never makes it into mainstream water treatment documentation. Building your own system requires 4 components. First, the ceramic filter unit itself. These can be purchased from organizations like Potters for Peace or constructed locally from a mixture of clay and combustible organic material, such as sawdust, which burns out during firing to leave a porous structure. Pre-made ceramic filter pots are available online for between $2 and $12, depending on the source and supplier. Second, a food-grade plastic or ceramic container to serve as the lower collection vessel. Any large food-grade bucket will work. Third, a spigot to attach at the base of the lower container. Fourth, the colloidal silver solution itself. A small bottle of elemental colloidal silver, typically a 1-ounce bottle at a concentration of around 10 to 20 parts per million, costs between $3 and $6 at most health food stores or online retailers. This is sufficient to coat multiple filter units. The application process is direct. Clean the fired ceramic pot with clean water and allow it to dry. Paint or pour the colloidal silver solution onto the interior surface of the pot in a thin, even coat. Allow it to dry completely. Repeat the application once more for full coverage. Place the coated ceramic unit inside the upper portion of your 2-container setup. Fill the upper unit with source water. The first pass-through should be discarded as a precaution. After that, water that filters through is ready to drink. Flow rate runs at approximately 1 to 3 liters per hour, depending on the density of the ceramic. A family of 4 can produce all the drinking water it needs in a single day with a single unit. The cost comparison is unambiguous. A single ceramic colloidal silver filter system, built from scratch, costs under $15 in total materials and lasts for years. A countertop reverse osmosis system costs between $200 and $600, requires filter replacements every 6 to 12 months at $40 to $80 each, and needs electricity to operate. A whole house water filtration installation runs between $1,000 and $4,000, including labor. Bottled water for a family of 4 in the United States runs between $50 and $100 per month. The ceramic silver filter produces the same result consistently for the cost of a lunch. It is worth standing back for a moment and recognizing the shape of what we are looking at here. Cyrus the Great crossing the deserts of the ancient Near East with silver jars on his supply wagons. Roman households keeping silver coins in drinking vessels for reasons they could not yet explain biochemically, but observed to be effective. Han Dynasty China, eating with silver utensils and storing drinking water accordingly. Tsar Alexander's army hauling silver-lined casks across the Russian winter campaigns of 1812. NASA engineers in Houston selecting silver ionization over every other available method for the water systems of the Space Shuttle. And a team of researchers at the University of Virginia publishing data in 2008 confirming that a fired clay pot coated with $3 worth of silver solution removes up to 100% of bacteria from drinking water. 25 centuries of independent discovery converging on the same answer. A $3 solution to a problem a $350 billion industry depends on you not solving. If this video made you think differently about the water you drink and the money you spend, share it with someone who pays for bottled water every week. Subscribe for more episodes where we follow this kind of thread wherever the history and the data lead.